All right, well, let's get started. Welcome to the Salt tuning and troubleshooting session. My name is Raine Curtis, and I work at SaltStack. I'm the training services manager, as well as with a lot in the spirit of a kind of a smaller startup company. I also go out and do consulting and on-site and work with customers. So try to incorporate some of that in this session. What I want to do, though, is I want this to be really interactive, because I know that a lot of us have different levels and different aspects of service and support. And so as we talk about things, I want to go through some scenarios. I want to make sure that you guys contribute your experience to this as well. So what I'm going to do is, rather than do a slide deck, I want to just start going through some scenarios, and then we can talk about things that we would do. So what I'm going to do is, let's come in here. All right. So as a Salt administrator, I run this command, and it's not working on one of my systems here, right? It's not working on the master. So you guys have had some experience with Salt. What are some things we could do to troubleshoot this? Call it locally, read the error codes, okay? Let's take a look at that. And when we say locally, what command are we going to run? Okay. And we'll just grab this. And why do I want to run it locally? What's that going to give me? Okay, it gives me the minion output, right? So I've got the return data, right, from the Salt command through that remote execution call, but I may not get all the information that minion, right? I'm only getting what's being returned back to the master. Yes? You do what? Okay. Is that the little t or big T? Isn't the big little t is for authentication, isn't it? So, oh, I'm sorry. You're talking the T command. I apologize. Sorry. Okay. Let's before we do that command, let's take a look. So, for example, if we were this is just an execution module. So maybe one thing is maybe do a different logging level, right? So if I do, like, let's say a debug logging level, let's see what that says. So here's some of the return. So that's not going to show us. So it looks like maybe we do need to look at the Salt call. All right, does that help us? It does, right? So it's telling us when we run locally, that group doesn't exist on this system, right? So when I tried to assign the group ID to this user, it didn't exist, so that's why it failed. So there's not technically something wrong per se, other than the group's not there. Okay. All right. So we talked about that. We could run in debug logging level. We could run the call locally. Is there anything else we could have done? Okay. Which one? The Salt call? No, the original. The original, okay. Do I need a debug logging level? I don't know if I'm seeing more information on there. I haven't used it in this scenario, but I have used that in other scenarios. We're not really hitting the state system. That's why I don't know if that one would show us anything. Yeah. Okay, expect the minion log. Yep, so if we were to go to var log salt, okay, we see we have a minion log, we have a master log. Let's take a look at the minion. Yep. So it looks like, though, that is, yep, so there we go. So our minion log showed us that as well. Okay, good. Let's take a look at another scenario.
By the way, Raine, let me interrupt. For the people who are in the back here, if you want to answer a question, just raise your hand and I'll be over there with the microphone so everybody can hear you better.
Okay, so in this, looks like we're going to start off with just checking out some network interfaces. Already it looks like something's wrong, right? So we'll have to see if it gives us any error messages here. All right, so we have a timeout request. Master's not responding. Okay, so persist, verify the master's up. Worker threads may need to be increased. Okay, so this one actually gave us some things to do, right? So let's take a look. Let's see if the service is up. Okay, so it looks like the master's up. What else would we want to look at? Okay. Okay. Let's see what the log says. Let's jump down here. Not seeing anything. Anyone seen anything jumping out? Okay. It did tell us to look at this worker threads, right? Okay. So what are worker threads in Salt? Okay. Yeah. So anytime you issue a command, for example, like Salt star, right, on something, when that request gets once the command line interrogates it, it makes a connection to the local system through an IPC call, and it hits that UDX connection, that socket there. Once that happens, that's where it hits Salt, right, in the request server. At that point, that's when the job ID is assigned, okay, when that thread is created. Once that thread's created, right, or we call them worker threads. Technically in Salt, as they are today, they're forked processes, okay? So we need to know how many processes are we going to have so that when returns, as was mentioned, come back, we're ready for it, right? So when that happens, we need to make sure that we have enough threads. And if you have like 10,000 minions and you issue a command and now you're getting 10,000 systems coming back, that may overload your master. So having the correct number of worker threads and enough is important. What about, though, if I just say, hey, the default is 5, but I want to always make sure I have enough worker threads, so I'm going to set it to 100. Is that good? Right. So just like with any other type of daemon, you want to make sure that usually you don't want allocate more threads than you have cores, right? Because of the context switching where it has to grab those processes, right? So if it's going to grab those, so for example, like if you have a 12-core system, I wouldn't set my worker threads higher than 10 because I want one for probably the system to get stuff done, one for the master, and then that would leave 10 worker threads for Salt to work on. So let's take a look and see what we have here. Actually, there's two ways we can do this. Let's do it the kind of Salt way. Let's do let's just do it. We don't have time. Okay. All right. And if you actually look in the documentation, it actually tells you need at least one worker thread, okay? So that's not going to work. So if we change that, back to trying to do this standing up. There we go. And then we'd restart the master, right? And then we'd be good to go. Now, someone's probably not going to set those to 0 in your environment, but what will probably happen is that you'll be running Salt, and as your environment grows, or you add more minions, or you start doing larger jobs, then you might start getting a message like that. And I've seen that with customers. Just so you know, the largest number of worker threads I've heard of was one of our developers went out from engineering, went out to a large organization, and they have set their worker threads to 50. But I would definitely say that that is out of the normal. Most of the time, I would say 5 to 10 is what you'd want to do, and you probably don't want to change it unless you are running into issues, okay? That should be doing that for us. There we go. Okay, let's take a look here. Now we're going to, looks like we're going to look at some pillar data. Oh, crap. It's not supposed to do that. It's supposed to be broken. Well, that's what the pillar's supposed to look like. Let's try that again. Now, as far as large jobs, when we talk about number of worker threads, before we jump into this, the other thing you can think about is, has anyone ever used batch mode? Okay, all right. And has that helped when you have large jobs? Okay. So when you do batch mode, like if I do batch, -- batch, and do like 10%, if I have 1,000 minions, then it will publish that job at 10 at a time, right? And it doesn't do like the first 100 and then the second 100. What it is, it's a rolling one. So as one comes back, it publishes up another one to get through those 1,000. But batch mode is another option you can use. All right, that one's not working. Okay, let's move on. Let's see if the next one will. Okay. Well, already we kind of have an idea that this might have something to do with a state, since that's what we're running here. Okay. So what do we know from this error message? What was that? Okay. So there's a specified SLS in a install Apache Top in Salt environment base is not available. Okay, so let's take a look here. Let's do a Salt. Actually, we probably just need the master. Sorry. Okay. So there's the states that are in there. And one of the advantages of doing list states, I mean, I could have just gone to that directory and did a directory listing, right, my state tree. But one of the advantages of doing like a CP list states is that's actually going out to the minion, right, that I'm trying to run this state on. It's going to that minion saying, hey, what do you see as states, right? And then also we see that, our states are, the directories are delimited and not / delimited. But it does let us see what's out there. So it looks like in here we have install Apache that was in this base environment, but we don't have an install Apache, right? We have, Apache Top. We have an Apache Top. So now we should probably go in and look at that state, right? Whoops. Okay. All right, looks like that might be a problem because we can't include a state that doesn't exist. So let's fix that. Okay. All right, and let's run that again. All right, so we don't see anything in red on here, but we do have something that was returned in here. Okay, so as we look at this, so now we're going to say for the service for HTTP setup, for this Apache 2, and the running function, let's take a look and see what that looks like. There's our HTTP setup. And notice in this case, I've actually got multiple state runs declared underneath the identifier, right? So I've got this identifier, which is that guy right there. But here's my first state run, which is the package install. Here's my second one, server.running. So those look good, because I didn't complain about any of those. But it did say it was a requisite, right? So the watch, if we look in here, here's a package, okay? So if we look up here, here is our package, and there's its identifier, okay? So this brings up a couple of points we need to understand about this. If I'm going to reference, if I'm saying, okay, I'm going to watch the package, what is that watch declaration doing? Right. So the first time it runs, if it actually installs a package, or it installs Apache, then there was a change, as was mentioned. Yep. But the second time, if I were to apply this state like a week later, it would say, hey, the package is already installed, there's no changes, right? So that means what we're saying is, since it's declaring the service, if there's a new version of Apache that gets laid down, I need to restart the service. I might already be in a running state, but there were changes in the package, so I'm going to restart to load up those binaries. Okay, so a watch does two things. It looks for changes. It also affects order. So if that HTTP setup package install happened to be below that, the watch would actually tell it to execute before, because it has to know if there are changes. So a watch does change, and it also watch change, and it affects order. Okay, so the package, the next thing I want you to see is, after package, it says HTTPD setup. Okay, is that correct? Okay, that is correct. But there's also another correct answer. Let me show you what that could be. Now, this one's a little weird since the name, you can reference that package.installed either by name or by its identifier. Okay, we're doing it by the identifier. Now, since the name's being represented by pillar data, let's just assume like this is Red Hat. So if we did that, that would also work if the package name really was HTTPD. Okay? So when you make a reference in a requisite, it can either be done by its identifier, which would be HTTPD_setup, or it could be by the name. Okay? So either way is going to work on there. So let me just undo that for now. But I just want to make sure as you're troubleshooting those, you understand those references. So here this says, here's the state module, and then there's the identifier for it. Here's another file state reference and the identifier. Now we have a require. So a require just affects order. So it doesn't look for changes. Okay? Also, when you do a requisite, it does one other thing. And that is, when you do a requisite, it all of a sudden, I shouldn't say all of a sudden, but what it does, it changes the execution methodology, meaning what it's going to do is it enables short circuiting, okay? So if I just had a state without any watches or requires, it's just going to run through it, okay? If that package install failed, well, it's still going to try to install a service that's not there, right? And if other things fail, you're going to get a whole screen of red stuff. If I do a require a watch and enable requisites, that enables short circuiting. So now it says, hey, if that Apache install didn't work, well, then don't try to do anything else. I'm going to kick out now. So you can do that behavior, enable that type of behavior with requisites, Or you can, in your master configuration, if you want that just global, whether someone uses requisites or not, if there's a failure, you can put a fail hard and set that value to true in your master configuration. Or if you want it on a specific minion, it can do that. And then that way that state run, any failures will fail hard there. Okay. We see that we're looking for a state module called install. Okay? And we're looking for install, and the reference is install _ Apache top. So the first thing is, do we have an install state module? Okay? Well, let's look at this file here. Okay, there's no install module. We could probably look at the docs and see if there is anything in the docs that would be related to that. Okay? But we'd also want to look at that Apache top module. So let's come in here. Okay, there is an install Apache top declaration, but it's actually looking at the package state module. Okay. So now when we go back and look at it here, there is no state module called install. Okay. But there is a package top. So because we included that, we included Apache top in this state, now we can set a requisite for it, okay? So now we're saying I'm requiring Apache top to be installed as part of my Apache installation, okay? So I changed that to package because, let's do this. Because that is the package. The actual state module that I'm calling is a package module. So that's why I'm referencing that. And then, like I said, I can either reference it by, after the state module, either its identifier, which is install _ Apache top, or its name, Apache top. Either way works. I just, right here, can't call it install. I have to call it package. So now let's come in and run that. Take a look. Okay, there's another issue we'd have to look at, right? Apache top's not found. Those are set to be installed. That's set to be installed. Okay, so now let's go to serve salt. Whoops. Okay, we were referencing a file here, so there's a problem. But it looks like I've put those files in here. So even though it's not in red, right? A lot of times as we're writing states, we think, well, there's no red, so things are good, right? When actually this state would fail. So I'm going to come back up and edit that state. And okay, let's see. Okay, so now there's no message that it couldn't be found. So I did find it on the Salt Master, right? Okay, any questions or comments about that state and how we troubleshot our problems there? Okay. I think I might need everyone to look away while I type, so I can type better. All right, well, that was quick, wasn't it? Okay, so let's see here. So now we're going to do a show low on here. All right, Jinja syntax. We love Jinja syntax errors, don't we? No, we don't. All right, but let's see here. We did get some help in this case. So we're going to see, okay, so rendering the SNMP conf state here, there was a syntax error, it even tells us the line that it's on. So that's a good place to start. And it looks like it even shows us. So it says an expected token, end of print statement, got salt on line 12. Okay. Which state was this? SNMP. Okay, line 12. Okay. So if we're looking at here, so what was the difference between in Jinja a curly brace percent and double curly? Okay, yeah, we're expressing output, right? It's an expression. So if we look at line 12, what's wrong with line 12 here? Yeah, we're trying to set a value. We can't do that. We can only express it, right? The set would need to be in a line that has a curly brace percent. Okay, so we'll have to get rid of that. And it looks like we're just grabbing pillar data, which is probably already set, right? And we're just accessing that pillar dictionary to grab that. So let's take a look here. All right, that looks like it cleaned it up. Okay. All right, that was pretty easy. All right. Looks like now we're going to look at a RenderState. Now, one other thing to note that this session was called Tuning and Troubleshooting. We're doing a lot of troubleshooting, but when we talk about like accessing pillar data, it's important to know that pillar is a lot of times it's an expensive operation. And the reason why is for a couple of reasons that we should know about. Let me ask, first of all, does anyone know why pillar is a more expensive operation than maybe other salt operations? Okay, it has to go to the master, okay? And when you say it has to go to the master, what does that mean? Okay, yeah, so if it's gonna run this and it says, hey, go get pillar, then it's gonna go to the master and get a pillar, because we define pillars on the master, right? The other thing that's happening with that is we say that like grains are grains, a lot of times we even say are insecure, but actually they're pretty secure. But pillars, we say, are secure, okay? And the reason why we say that is because when we talk about grains, right, and because the master caches grains of the minions on there, and all the minions get to see each other's events, right? So a lot of times we say, well, that's kind of insecure. Well, it is shared information, but it is pretty secure. And the reason why is because, one, the RSA keys are authenticating each other, right, the master to the minion, but that data is all encrypted through an AES key, okay? That's what the payload is. The reason why we say it's insecure is because that AES key in of itself is shared. Everybody has the same AES key, okay? Salt's looked, we brought in security consultants and talked about it, and performance goes way down if we have a unique AES key for every minion, especially as you start scaling up. So we figured we are keeping things encrypted, but it is a shared AES key, except for pillar data, right? Because we say, hey, if you need to put like a password in a pillar, it's secure. Well, what happens is, and this goes to why pillars, you don't want huge pillars, is because if he has to request that pillar, the minion, when in that request, negotiates a new session. So there's a temporary AES key used just to go get that pillar data to bring it down in that situation. So once he has the pillar, it closes out the session. So every time you do a pillar request, it has to negotiate that new AES key and to pull it down. So there can be overhead on that. Also, since we're talking about AES keys by default are rolled over every 24 hours. So the master will roll that key over and say, hey, everybody, we need to have a new AES key, and here's what it's going to be. If you delete a minion, then the master will roll that over. So there's some settings you can put in there as far as random times and things like that, and re-authing. I believe if you look in the docs, it's running salt at scale. And there's some things talking about the thunder herd, right? When the master says, hey, I'm rolling the AES key, and then you'll see all those connections come into the master, okay? All right, that was kind of a tangent for a state troubleshooting section, but at least we understand pillars a little bit more.
So would it be better to reference that pillar that is set into a variable so it makes that request a single time, or do you have to do it 3 times you have listed?
Well, so yes, if you were going to use it multiple times, I would declare it at the top of my state and then just put it in a variable and then reference it multiple times instead of having to do 3 pillar calls. Now, the other thing on there, in large, and this is getting into maybe a little more work than maybe is necessary, but if you really do get it to a lot of performance issues, because a lot of times pillar data is even coming from an external source, right? We have an external pillar that's maybe going out to a CMDB, presenting that as pillar data, and then we're calling it, right? So I had one situation where I went on site where we were looking at performance issues. They were doing just that. They referenced a pillar. The pillar hit the external pillar configuration, which made a RESTful call out to a CMDB that brought it back, built the pillar data, presented it, and then sent it back to the minion. Well, this system wasn't very fast with its RESTful interface. It literally was like 5 seconds, right? And in coding, that's really slow, right? So we're hoping for like milliseconds, right? And but it was slow. So there was nothing we could do because that RESTful call was taking so long. What they did do, though, is they said, okay, we can't do anything about that. So what they did is they put a new server right next to the Salt master that made these RESTful calls and cached the data local. And then they just accessed that much faster, and they could get their data. The other thing that they did is they were bringing everything that was in the CMDB, everything that you could know about a server, they wanted in pillar data. So they had these huge pillar structures in there. So what they did is they said, okay, if I do a pillar thing or request, they limited how many times they're referencing pillar. So they would take their pillar and they defined grains in their pillar, okay? So they took pillar data and accessed grains. Well, grains we know are local to the minion, right? We can access grains much faster than we can pillar, okay? So it gets in a little more of a sophisticated and extensive configuration, but you can define a grains pillar and put all your grains in there. When the minion pulls down, references that pillar, it now has that grains definition on the minion itself, and then you can access it locally, okay? So that's another way to address that. Yeah?
I know there was some work being done on getting things like like package installers to aggregate a list of all of the packages that needed to be installed that were defined in the state and do a single YUM install of all those packages. Is any work being done to optimize pillar calls? That's three key negotiations. That's ridiculous.
So I'm actually not sure if that's 3 key negotiations or if in the state run he looks and makes it as 1 negotiation, but it's still 3 calls, right? Yes, there actually is work done recently. So it's so recent, I'm not sure if it's actually released yet or if it's still in the dev branch. But one of our engineers, Mike Place, if you had any sessions from him, he actually just wrote so that you can enable like grains and pillar caching. So you could say, you know what, my pillars don't change very often, so there's some settings on how often the minion will need to cache. So I believe the way it works is if he says, hey, I've got this pillar call for a grain, and my time of when that's expired hasn't happened yet, then I'll just look and see if he's in my pillar cache and use that value. So I believe that's how that works. But yeah, he just wrote that for that reason. Any other questions? Yes?
So where is actually the base render on the master?
That's a great question because I think it's misunderstood a lot. The state is actually rendered on the master. What happens when you tell it to run a state, right? The event gets published on the master. The minion's looking at that port, right? 4505, that publisher subscriber channel. He pulls the state down, okay? He's looking at that state, and the first thing is that it's rendering it, okay? And as he renders it, he's starting to look at what resources do I need. And it says, oh, well, wait a minute. It told me to go get a redis.conf, right? So then he will make another call back to the master and say, okay, let me go get that Redis conf. Or excuse me, actually I skipped a step, I apologize. He looks at the function and says state.sls. Do I have a Redis state? If I don't, I'm going to go out to the state tree up on the master, right, and see if there's a Redis state. If there is, then he pulls it down. Then it looks at the state and says what's in there. So that state will be cached on there for the minion to render it. Then he looks to see if he needs resources like files and things, bring them down there. And that actually is a forked process, okay? When that request comes down. Once the minion looks and says, I've got a function to run, like state.sls, then it forks a process. Now, it actually double forks the process. Now, does anyone know why we would do a double fork? What? Okay, to detach it, right? Because that's typically what we do with daemons, right? Is so that when we log out, like Apache stays running after we start it, right? And so, well, why would we do that? Why would we detach it from the parent? Okay. Okay, but why wouldn't we want to keep it tied? Okay, that's one great scenario. And that was one of the strong use cases, because what if that state had in it to restart the salt minion process? Well, he kills his parent process and he just killed himself, right? So that doesn't work. So that was one of the main use cases. The other thing is because if the minion does die for another reason, we still want that work to continue, right? We want that to run. So you will see that fork process happen. And within that process, you're going to see the rendering as well as it pulling down all of that. And then it will return. That will be the process. And a lot of times in documentation, you'll see references to that called the jobber, the job process. And one of those, so every time he gets one of these states to run whatever, or function right, like a state.sls, he forks another process. So if he gets another job, he can fork that if that one's still taking a while. But then he'll return the data back to the master, as we've seen. Okay? Any other questions? Okay, let's jump in and look at this one. All right, let's see, what line was that? 22, okay. 22. Okay, what do you think? Okay, single quote. Yep, let's put that in there. Right? So if we're looking at this, we've got a nested pillar, right? We've got a pillar named Redis, and under Redis, if we looked at the YAML, we'd have Redis colon, and then under the next line, we'd have port colon, and we want to get that port value, okay? That's what we're seeing in this reference. All right, so it looks like we got a different error now. Okay, variable dictionary object has no attribute, okay. iFace, okay, so let's take a look here. Well, first of all, before we look back at the state, what is that saying? Okay, it doesn't exist, right? So one thing I may want to do is, let's see, this is on menu 1. I could come in here and I could do a pillar.item Redis. Let's take a look here. It was looking for iFace. Yeah, there's no iFace there, right? So I don't know what someone's thinking when they wrote this, but that doesn't make sense. They might have meant that, right? The interface, right? So, and how we want it to bind. Let's come in here. So the interface, so we could do that. Now let's try that. Okay. So that's looking good. What does a ShowSLS do, right? SLS runs a state file, a salt state file. What does a ShowSLS do? And why am I doing that? What was that? It renders it, yeah. So the first step in the state system is to render this SLS file. So we'll see that used quite often. So when we talk about, we have SLS files for many things, right? So that was one of my questions when I first started looking at Salt is, okay, wait a minute. So I understand this SaltState, SLS is, that's what it's for. But then there's a .SLS for pillars, right? And then there's a .SLS for reactors, right? And there's a .SLS for orchestration. Why didn't we use different prefixes and things, right? Well, if you look in the documentation, it says a SLS file references a state file. Well, guess what? All of those interface with the state system because the first step in the state system is to render that file. Okay? So that's why we do .SLS for all of those things because we're going to render that file, but then if it is a state run, then we're going to start compiling it, right? We're going to worry about order, look at those requisites, requires, worry about ordering, convert it, and then in that process we'll convert it to low data instead of this high data, and then we'll execute it. If we're doing a ShowLSS, we're only going to that first phase of the rendering, right? We're rendering it and then we're stopping. If I do show low, then it renders it, also renders it to low data, and in that process, the reason why I do a show low sometimes is because sometimes those Jinja variables don't get rendered, as depending on which level they're at. So if I do a show low, then it's had to evaluate everything to put it in low data to execute. Now I just referenced high data and low data. What am I talking about? What is low data? What is high data? What? A rendered state?
Low data is like representation for low level representation.
Okay. Yep. Both are rendered. Yes, both are rendered. So let me put it this way. When you write a state and you write like YAML and Jinja in there, let's just keep it simple. Let's just say it's just a YAML state, right? That SLS file is actually a representation of high data. Okay. Once it goes through the YAML renderer, then it will, once it goes through the YAML renderer, it returns high data. And when we talk about high data, we're talking about a specific data structure, and even more specific, a Python dictionary that Salt's going to interpret and say, these are my instructions for this state to run. Okay, once he does that, but then it goes through a low state compiler, and that low state compiler is important because at the low state, now it's broken into smaller pieces that Salt can execute more efficiently. Much like source code versus binary, right? Puts it in format. And I've actually talked to Tom Hatch a couple of times about this, and I thought it was interesting that he's hardly ever had to change the compiler from high to low state, even with adding all sorts of features. So that part works really well. It makes it run more efficiently. Yeah? Let me think. I know I'm going to have to think about that. Because I know some people have done it, but I'm drawing a blank right now. So let me think about it for a minute. Are we about out of time? Okay, I heard the applause. So let's take two more questions, if anyone has any. Yeah?
So essentially, high data is the first level of rendering, and low data is the second level.
Yes. Yes. Yes, that's our order. So see how there's an order assigned? Let's see. Oh, sorry, that's pillar. Let me just run this. Oh, sorry. Yeah. So see how there's an order assigned, but anytime you do a show SLS, you don't want to look at order. Like if you say, wait a minute, what is this? This is my, is this my service? What is this? File. So there's the file. And I'm like, wait a minute, a file is supposed to happen in a different order. When I do a show, I don't want to worry about order on here. The best way to look at order is if I run a state.sls and do test equals true. That's really going to show me the order because I know everything's been evaluated at that point. Okay? One last question? Okay. Hey, thanks, guys. Appreciate you coming.